Good morning, everyone. Hope I'm audible. Please confirm via chat. Okay, thank you. So we'll continue with our projects. So yesterday we saw a data set with respect to loan classification, right? So today I have picked a data set related to, you know, employees. So we can consider this as, you know, something related to HR analytics. So I have shared the data set through the chat. You guys can download it. You can do it along with me, right? So let us start. As usual, let me import the basic packages. So I'll import NumPy, I'll import Pandas. Let me also import Matplotlib, right? So let me also say Matplotlib in inline. And let me import warnings, right? So I don't want Jupyter Notebook to display unnecessary warnings on my screen, right? For that purpose, I am importing warnings. Warnings dot filter warnings, right? So you are going to filter out the warning messages and you will be blocking it from displaying on your Jupyter notebook. Let's run these cells. Fine. So we have imported the basic libraries. Let us now read the dataset. I already have the dataset in my directory. I have also put up in your chat. You can download that. Dataset equals, so it is a comma separated value, right? CSV files. So how to read the CSV file? We have already seen that. Pandas dot read underscore CSV, and then you pass the name of the file. Ideally, you will be passing the path, right? But since I have stored it in the same path wherein I have opened my Jupyter notebook, let me give the file name as such. So this will be my file name. Let me also comment it out so that it will be easy for you when you are going through this notebook post session, right? So pretty simple data set, right? So let us now see what are all the columns present in the data set. But before that, like I told you, like we did in the last project, it is always a good practice to take a copy of your original data, right? So let me take a copy of the original data. So why we are taking copy? See, the thing is here the data set is small so that you are able to upload it just like that. But imagine you are working with a larger data set, right? Let's say you have 5 lakh, 10 lakh rows. So in that time, so every time you try to push it into your Jupyter notebook, it will take some time, right? So that is why it is always a best practice to save your, or I can say take a copy of the original data and try to work on that. So then and there, it is better that you take a copy, right? Say for example, I'm doing the null values. I'm handling the null values, and then I'm doing the encoding part. Post that, I'll take a copy. Then I'll go for handling the outliers as well as scaling. So the thing is, whenever you want to go back, right? So let's say I have, right? I have done the sampling, right? I have done the oversampling. Now the thing is, I want to go back to the original data set. Right? So again, what I need to do, I need to run everything from the scratch. So in order to avoid that, as and when you do some steps, take a copy of the data set so that it will be easy for you to traverse back to the original required data, right? So first let me take a copy at this particular point, right? So you have a function in pandas. So let me call this as first copy, right? Dataset dot copy. So by doing so, you have taken a copy of your original dataset, right? So the thing is, whenever you want to go back, you can just come at this place, execute this line, and then get the dataset stored at this particular point. Clear with this? Able to understand? Yes, Suman. So it is the best coding practice to follow, right? Say for example, so let's take this example. You are doing the encoding part, right? So you have label encoding as well as one hot encoding. Let's say you have proceeded with one hot encoding, right? And then you have done all the possible steps, and then you see that your performance is not good, right? And then okay, you are deciding, why not I try label encoding instead of one hot encoding. So in that case, what happens, you need to again run your notebook from scratch. So in order to avoid that, so what you generally do, once you have completed your handling of missing values, take a copy of the dataset, right? So that when you want to change the encoding, you will be moving to that part of the code wherein you have taken a copy of the dataset post doing the null value treatment. If not, right, let us say you're not taking such dataset copies then and there, then what happens? You need to run everything from scratch. Number one, computationally it is waste. Don't think from the point of view of a smaller dataset. Think from the point of view of a very large dataset, right? Computationally, the resources getting waste. Number two, your time and effort is also getting waste, right? So the thing is, you need to take the copy of the dataset as and when required. Clear with this, everyone? Fine. Now let us see what are all the contents present in this. Let's say I want to visualize first 10 rows, right? So you have age, attrition, business travel, daily rate, department. Don't worry, whenever you are provided with a data set, right, they will provide also metadata. Metadata means data about data. That means you have all the columns, right? You have all the columns. Your metadata contains information regarding what each of the column actually represents. So logically, we can say this represents age, this represents whether they have traveled with respect to business or not. This represents the department, right? So these things are commonly, we tend to have knowledge regarding these words. Since we are working on an employee data, we already have that knowledge. Let's say you are working on a different domain. Say, for example, you are working in a healthcare data set, right? So they will give you parameters, columns related to health information, right? So in that case, you won't be having any idea like what this column is denoting, what that column is denoting. So for that purpose, they will give you the metadata. That metadata contains what each of your column actually represents, right? Clear with this? Fine. So let us also check the last 10 rows. And one more thing, it is also a good practice to scroll and check the end of the columns. Sometimes what happens, you know, by mistake, your pandas.read CSV, right? It will also try to read in empty columns, right? So that is why you always do this dataset.head as well as dataset.tail. Just in case if your pandas has read the empty columns and empty rows, in that case you can go and delete them. So in my case, I can see that it hasn't read the empty columns. Fine. Likewise, let me check whether it has read any empty rows. Fine. It hasn't read any empty rows. Let's say if it had read any empty rows, in that case you will be getting NaN values throughout, right? Likewise, if it had read any empty columns, you will be getting a column named unknown and then you will have NaN values throughout. Sometimes this happens, so that is why it is a best practice to always check on with the first 10 rows and last 10 rows. So that gives you some idea whether your panda set has read the unwanted columns and unwanted rows. In our case, fine, everything works fine. Clear till this point, everyone? If you have any queries, you can post it in chat. I'll address that. So far, so good. Fine. Okay. Okay, fine. Now let us see some general information regarding your data. What is the code for that? We did this yesterday. Try to recollect it. Wherein you get the total entries, you get all the columns, you get the data types of the columns, you get the non-null count. Exactly. So you have something called as info, dataset.info, right? Which says that your current dataset is a data frame, right? And that you have 1470 rows. And you guys know indexing starts from 0, right? So you have indexing running from 0 to 1469. And in total, you have 35 columns in your data set. So these are all the columns. And then it will also tell you the type of the column. So whether it is an integer or whether it is an object or whether it is a float, right? And one more thing, it will also tell you the non-null count. Suppose for example, we have 1470 rows and in the age column, it is saying it has got 1470 non-null content. That means I don't have any missing values. Null represents missing values. Let's say in this case, right, we have 1450. Let us assume that. Let us assume in this case we are having 1450, right? If it has 1450, then have a look at this. Here you have 1470. That means 20 null values are present in your age column. This is one way of checking for null values, right? Clear with this? Now, what is the other way of checking the null values? What is the other way? The other way is you have a function called as isNull. Checking for null values. So dataset dot is null, and then you want to say how many null values are present in each of the column. For that, make use of sum, right? If you run this piece of code, you will be able to see the columns and the corresponding null values. So it is saying 0. That means our data set doesn't have any null value. So this is also, you can also cross verify from here. So you can see everywhere you have this count 14, 1470, right? So that means you are not having any null value in your data set. So one job is done. So we don't have to do the part of handling the null values since our data set doesn't have any null values. Clear with this step? Now what if we had null values, right? We have already discussed this during the pre-processing. So if your, you know, if your column is categorical, right, you fill it with mode, right? And if your column is numerical, you check for the outlier, and then if no outliers, you can go for mean. If there are outliers, you can go for median. So this part we have already discussed, right? So in this case, we don't require that because we don't have any null values, right? And if you look at the metadata, right, this is the particular column that you want to predict, right? So this will be your dependent variable. So what is your dependent variable? Attrition is our dependent variable. So our task is to model such that the model is able to predict whether attrition takes place or not. So given these characteristics of an employee, we need to predict whether he or she will be leaving the organization or not. So that is what you mean by attrition, right? You would have also seen in news like, okay, for this quarter, so and so company reported so and so attrition percentage, right? So that means the number of employees that they are, number of employees that are leaving the organization, right? So what business use case do you think this particular model gives to the company? So the thing is, based on the employee characteristic, the HR department, they can have some idea, okay, whether this employee is likely to retain in the same organization or he or she is likely to quit the organization. So that gives them a basic idea in beforehand so that they can plan their workflows, right? So if you guys, if you have worked in the HR department, so they used to forecast for the next 3 months, like what might be the headcount and what is the requirement. So based on that, they can allocate the resources. So it is better to know about the attrition beforehand so that they can plan it out, right? So that will be the main business use case working on such data sets. Getting the point? Fine. Okay, fine. Yes, yes, Priya. This is the thing you want to predict. So other things will be the independent features. Fine. Now let us see. Let us plot this attrition column. Let's see what percentage are present. With the help of a pie chart, let's do that. Data set of attrition dot value counts. So let me run this particular line first. So you can see that our column attrition has got two values. One is no and the other one is yes. Fine. So let us now try to visualize this in the form of a chart. So it will be better that I use pie chart. Fine. And then let me say plt dot show. So able to see the pie chart, right? So you have 83.9 percentage belonging to no, 16.1 percentage belonging to yes, right? So this is the distribution of your attrition column. So getting the idea, getting some idea about your dependent variable.